Hello, my name is Brian White. This is my course project proposal for Network Support Management. Let's go ahead and get started. I wanted to start by setting up the network side by side and obviously comparing the both of them and naming out what kind of hardware we're looking at here. The networks are consistent of basically the same hardware, just at first glance. They start their first networking layer after all the users would be the switches, and they both have a mixture of Cisco 10100 24-port switches and Cisco 10100 1000 24-port switches. No specific names, just the speeds of the switches and how many ports they have. Of course, they both seem to be split pretty evenly, 50-50. Half of them are the 10100s and half of them are the 10100 1000s. And then after that, a layer of routers, which is a mixture of Cisco 1841 routers and Cisco 1941 routers. And then after that layer is the outgoing router that they're all connected to, and on the West Coast network it's a Cisco 1941, but on the East Coast network it's a Cisco 2900. This could be because of the significant increase in users on the East Coast network. Maybe they needed a more powerful router, I don't know. But there is a difference here in the router. For the upgrade, we had some needs that needed to be met. The requirements included gigabit Ethernet speeds, IPv6 capabilities, and room for a 20% growth in the user base for both networks. It wasn't specific for each network. It was just these were the requirements that needed to be met for both networks. I'm going to go ahead and explain what hardware I was looking at upgrading with for the Cisco 1841 routers, 1941 routers, and the 2900 router. I was looking at going ahead and upgrading using the 4000 series of the Cisco routers. It is a newer series. It's up to date, pretty quick. It's a good router to go ahead and upgrade with. For the switches, both the Cisco 10100 switches and the Cisco 10100 1000 switches, if I was going to upgrade them, I would have used the 9300 Catalyst switches. I think that is their newest model. If you don't look at the 9400, which is the newest model, I believe. Let's go ahead and talk about the Cisco 4000 series. Like I said, I believe that is the newest series of routers. It seems to be very cost effective. Actually, even though it's newer, it seems to be relatively less expensive than some of the older router series, and I'm not sure how that works, but it works. It's very capable of the gigabit Ethernet speeds that we're looking for. Multiple gigabits, capable of being handled per port in the router. And then the IPv6 capability is there. It is compatible with it, and all that needs to be done is obviously just configuring the IPv6. Plus the fact that there are multiple options for the routers, because it is a whole series, 4000 series. There is the Cisco 4331 and the Cisco 4351. The 51 is more powerful, but I feel like that much power might not be needed for our upgrade, because we get everything that we need out of the Cisco 4331, and the 51 is more expensive because of the extra power. For the switches, I chose to go with the 9300 Catalyst switches, simply because it can keep up with the gigabit speeds. They're technically 10100 1000 switches, so they can keep up with the gigabit speeds. They're more powerful than a lot of the other ones. Like I said, they are some of the newest routers. There's the 9300 and then the 9400. The biggest reason why I chose the 9300 was simply because of the amount of ports given by the 9300. The 9400 only had a couple of options ranging from, I want to say, a 7-port switch, I think, and a 12-port switch. So those wouldn't have worked. We needed the 9300 Catalyst switches, which is okay. They're still very new, very capable, and very fast. Why upgrade? Well, let's go ahead and move through the hardware and why we need to upgrade each hardware piece. The 10100 switches are just simply not capable of keeping up with the speeds. Gigabit Ethernet is basically, gigabit. So 1 gigabit is 1000 megabits, which is what the 10, 100, 1000 stands for. 10 megabit, 100 megabit, 1000 megabit. So obviously the 10100 switches are not capable to keep up with the gigabit speeds because they aren't 10, 100, 1000, so they don't offer the 1000. The Cisco 1841 routers need to be upgraded simply because they're not capable at all. We need to have IPv6 compatibility. The 1841 routers do not offer that compatibility. And at the same time, the 1841 routers aren't capable of keeping up with the gigabit speeds. They are, after all, very old and actually aren't even manufactured anymore by Cisco. You can't buy them anymore from Cisco. They're out of date, underpowered, and they need to be replaced for any of these requirements to even take place. The Cisco 1941 routers are basically the exception to the rules. They are still manufactured by Cisco. They're not too out of date. But this doesn't stop the fact that they may not keep up with the amount of speed needed for gigabit. They're technically gigabit routers, but they are older than the switches that I'm offering and recommending. We can keep the 1941 routers if we need to, but I would say for this round of upgrades, maybe go ahead and replace everything that needs to be replaced. And then here in another year or so, if you want to, you can replace the 1941 routers to make sure that everything is up to date and everything is good and capable. But right now, the Cisco 1941 routers don't need to be upgraded because they do offer IPv6 compatibility and they are technically gigabit Ethernet routers. And then the outgoing routers is something I'd like to talk about. On one router situation, it's a 2900. It's a good, powerful router, nice and easy. It should be able to handle the speeds, and it is IPv6 compatible. So it's not necessary to upgrade to that router. It's good and quick. Now the other network, I want to say it was the West Coast network, had a 1941 router. It was smaller. The network was smaller, and it probably didn't have near as many needs. But the West Coast network still had a 1941, and I would say it might be a little more necessary to upgrade that due to the possibility of bottlenecking traffic through one low-speed router. If we're going to keep up the gigabit Ethernet speeds and everything does kick up and pull out multiple gigabits of speed per router, that 1941 router might not be able to keep up with the high-speed internet that we want. So after all upgrades are done in the network, the first network, this is the East Coast. This is basically what it'll look like. All the users are there, all of the things are there. The 1941 routers are left alone, as I said. They're not necessary to upgrade. They have the speed requirements as needed. They are just fine where they're at. But for future reference, you might want to replace the 1941 routers. They are going to be out of date eventually, but probably just fine where they're at for now. All of the 1841 routers are going to be replaced with the 4331 routers that I mentioned. This is truly exactly what needs to happen. It might be the cheapest route, but it might also be more expensive than the cheapest of the cheapest routes. But I would recommend going for the 4331 router just as an idealist looking into the future. We won't have to replace or upgrade these 4331 routers for a little while. Not until they come out with terabit speeds and we need to buy a whole new router to get terabit speed internet. But that's way in the future, and we can settle with the 4331s and be happy for years and years to come. The outgoing router doesn't need to be replaced. Like I said, it was a 2900 router. It's an optional upgrade. It does not need to be upgraded. But it's something that could be upgraded if needed, if wanted, and could help with future issues if we do it now instead of doing it later. And then, of course, all of the 10100 switches are going to be replaced with 9300 Catalyst switches, which are very fast, very capable, and will allow us to distribute our gigabit Ethernets as needed. Also, the 10100 switches are they have several different models that range from having as low as 12-port switches all the way up to having 48-port switches. So we can choose from there how many ports we want per network based on the growth needed. The 1841 routers in this network will be replaced just like in the last network. The 1941 routers are left alone except for the outgoing router. Like I said, we need to replace the outgoing router on this one just for future reference when the speed does pick up. I don't know if that 1941 router will be capable of handling all that speed. So in this network, I highly recommend going ahead and replacing the outgoing router and just making sure that it's going to work fine. The outgoing router should probably be upgraded, and that's just all I have to say for that. The 10100 switches, like in the last network, will be replaced with Cisco 9300 routers or switches. The end result of all of this is a total cost for the routers being $20,000 to $25,000, depending on who we buy the routers from. Total cost for switches being in between $21,000 to $30,000, depending on the retailer. The prices really fluctuate with the switches. Installation, man-hour wise, will take 1 to 3 hours per router, depending on how you want to install them. They can be plugged in and use backed up iOS images to make sure that everything is configured right, or you could reconfigure completely. Either way, it's going to be basically between 1 to 3 hours per router. The speeds will be gigabit or more, depending on exactly what you want, who wants it, and how fast you want it to be. Because all the replacements will be compatible with multiple gigabits of speed. And IPv6 is very compatible and just basically needs to be done. As you saw in the pictures, using unique local addressing, it is possible. As an end page, I just wanted to show you both networks side by side, what they are, just to leave you with something that you can look at. I hope that this was all that was needed, and have a good day.